Hey there. In this video we are going to look at the concept of a reference angle and how reference angles are connected to any angle in standard position. Every angle in standard position is related to a small angle that is called its reference angle. This reference angle is the angle that is between the terminal arm and the x-axis. It's a little different in each quadrant, so we're going to look at it visually here to get a better sense of what we're actually talking about when we use the term reference angle.
So we're going to look at an angle in standard position, which we're going to call theta here, this Greek letter, that symbol, theta, and its reference angle, which we're going to call theta subscript r, theta r for reference angle. In quadrant 1, the angles are already less than 90, so the reference angle is the angle itself. The reference angle is the angle itself. It only happens that it starts to be different when you get bigger than 90 here. So when we go into quadrant 2, let's say we stop at 120, the reference angle for this angle of 120 from that positive x-axis all the way over to there is the smallest angle between the terminal arm right here and the x-axis, and that smallest angle is right in here, this little blue. That's the reference angle. The reference angle is that acute angle that completes that down to the x-axis there. If we move into quadrant 3, so let's stop at something like, I don't know, 225 maybe. The reference angle for this angle from all the way over here, 225 to there, the reference angle is actually going back the other way because that's the closest way to get to the x-axis. The reference angle for 225 is 45 back to there. It's not this little extra part in here to 270. It's not to the y-axis, it's to the x-axis. So in that case, it goes, in quadrant 3, it goes back to the x-axis there. And then if we move forward into quadrant 4, maybe let's stop somewhere about there. For an angle of 320 degrees all the way around to there, the reference angle is this shortest way to the x-axis, that little acute angle in there of 40 degrees. It doesn't even matter if the angle is positive or negative, that reference angle is going to work the same way and is always going to be positive. So if we start out back here somewhere, and instead of looking at a positive angle, we're looking at a negative angle, and we work our way around here. Get that out of the way. So if we're going backwards this way, as we're going through quadrant 4 here, if it's a negative angle, that angle is just the positive version of that angle. If we get into this quadrant here, let's say we stop at 150 there, that angle of negative 150, going backwards that way, the reference angle is just that 30 degrees in there, and it's positive. The reference angle is always positive. Up here, same story. Let's stop there. 230 degrees. This you have to go back to get to that because that's the closest way to get back to the x-axis. And if this is 180, then that is 50 in there. And then if we go all the way over to here, stop somewhere there. If you've got negative 320, well, you're going to need 40 more to get to there. All right, to summarize, the reference angle is the angle between the terminal arm and the x-axis. It is always positive, even if the angle itself is negative, or 0 if it's an angle on an axis, a quadrant angle. So that means that it has to be between 0 and 90 since it's an acute angle. Now let's look at a few examples before we're finished here. So an angle of 70 degrees, probably about there, in the terminal arm, up like that, 70 degrees. In quadrant 1, the reference angle is the angle itself. So theta r equals theta, which is 70. 125, it's bigger than 90 over here, somewhere around there, is 125 in quadrant 2, obviously. In quadrant 2, the reference angle is that little angle in there, forward to the x-axis. So to find it, what we're going to have to do is take 180 halfway around, and then subtract 125, that angle, and that'll give us this leftover part here, which is the reference angle. So theta r is going to be equal to 180 degrees minus theta, or in other words, 55 degrees. 258, this next one here, bigger than 90, bigger than 180. It's almost 270, just a little bit less. Terminal arm right there, 258, which is in quadrant 3. The reference angle in quadrant 3 is this angle back to the x-axis. So in order to find it, what we're going to have to do is take the angle and take away 180 from it. And that'll leave us this leftover part here, which is the reference angle. So theta r is going to be theta minus 180 in quadrant 3. Or in other words, in that case, it's going to leave us with 78 degrees. 331 here, almost all the way around, just shy of it there. Terminal arm somewhere there, 331, which is obviously in quadrant 4. Now, the reference angle in quadrant 4 is that little bit forward to the x-axis. So in order for us to find that, we're going to have to take one full turn and subtract the angle itself, and it'll leave us with this leftover bit here. So to find theta r, it's going to be 360 degrees minus theta, which is going to leave us with 29 degrees. All right, so that is reference angles and how to find them.